Good morning, everyone. Today is May 24th, 2021, and week 14. This is the 14th week. Okay, after this week, we have 2 more weeks. So next week, we will continue to study, and at the end of next week, Thursday, we will start review. And the last week, the week of 16th, will be we'll have review and final exam. So welcome, Andy. So I was just talking about that this week is the 14th week, and we will continue to study. The last week, the 16th week, we will have the final exams, and of course, we'll have plan coming forward. And this week we have quizzes, and next week we will only have one quiz, and then we'll get ready for the final exam. Okay. All right. Do you have any questions about everything we have talked about so far? It's time to review. Okay, so let me write it down. It's time to review. If you have not started sooner. Okay, if you have any questions. If you have any questions, or if you cannot make it to the class and you have questions, please send them my way. Either by pronto or by, all these ways of being talking about the inbox. And anyway, I will get to those questions, and I see the submissions of your quizzes, and I will be working on those. And so this week you have 2 quizzes, and next week you will have 1 quiz, and the last week, the week of 16th, you're going to have final exam. Of course, we'll still maintain the regular schedule for this week and next week, and the last week, the week of 16th, and I will talk about the schedule later. Okay, so let's continue our questions. Basic 43A. Basic 43A. Okay, in this section, we were talking about that. I had a haircut, it was too short. Good morning, Bailey. Good morning, everyone. Good morning, Bailey. Good morning, Mikhail. And good morning, Andy. So let's continue. These are the topics, the 43A, these are the things you are going to see. And of course, for derivatives. So I'm showing you a couple questions. So let's continue with these exercises. As I told you, that most of these exercises are from calculus textbook, okay, in chain rule, in the section of chain rule. So what I'm trying to show you, whether whatever you do, just to know how to decompose. To decompose, okay, I've shown you some examples. We did number 1 and number 2. So let's start with number 3. How would you decompose it? This seemingly to be rather simple question, right? This is rather simple question. It's tangent pi times x. Okay, tangent pi times x. How would we decompose? Then you say, do we have to decompose this? And yet the answer is yes. You have to do a simple decomposition there, and thus you can apply the chain rule. Okay, you will learn how to use chain rule, but I'm not going to address chain rule. I just talk about decomposition. Okay, sometimes you as you're getting better at this, you don't actually do it. You don't need to do it explicitly. You do it implicitly. Okay, so the way I show you how to decompose is the way how you're going to view it when you do chain rules in Cal. Okay, for example, here, tangent, well, there's a derivative for tangent, but not for pi x. So you have to view this guy. Okay, this is how you view it. This is going to be tangent. You're going to view this as u. Okay, so your u is going to be the pi x. That's as simple as that. So you're going to differentiate this guy and then you differentiate that guy. Then you're done. Okay, that's how you would do it. So so let's look at how we compose the F, how we compose the G. The inside, okay, the inside, okay, is the G. Okay, so when we talk about F composite G, the inside is the G. So this guy is a G, G of X. And how about this guy? That will be your F of X. Okay, you just have to replace the U by X. You can use U, but it doesn't matter. If you use U here, this is your U. Okay, if you use X here, it doesn't matter because these are just placeholders, right? These are just placeholders. So that's how we decompose. Okay, and then you say, is there any guiding principle? Is there any guiding principle? What is a guiding principle? The guiding principle is order of operation. Is the order of operation. Okay, do you guys remember what's order of operation? Okay, please excuse my dear Aunt Sally, whether you know that or not, it doesn't really matter. Okay, so what does order of operation say? You know that, right? You start with parentheses and then the power, right? And then what? Multiplication left to right and addition left to right, right? Do we know that? That's the order of operation. Now, when we decompose, okay, I want you guys to draw the conclusion. Did I write the guiding? Did I write the guiding principle? I think that spelling doesn't seem to be right. Is it L? No. Guide. Okay, guiding. Is that right?
Yeah.
Okay. For some reason, I thought that was not right. Okay, so if you recall what we did was number one. Okay, because I want you guys to know, to have a tool. You have a tool that you know how to do it even when the teacher's not around, right? And the guiding principle, of course, the order of operation. How does the order of operation works? If you look at that, if you look at number one, we did, right? If you do order of operation, you're gonna do in the inside first, and then you take the cubic root, right? But when you do decomposition, what you do, you reverse that order, reversed, because you're gonna make this guy U, right? Did you see that? We make this guy U. It's the opposite of order of operation. You go from outside inside. When you do order of operation, you do from inside out. Do you kind of get that? So when you do decomposition, you're going from outside inside. Did I make myself clear? When you do order of operation, you do from inside outside. So the order is completely reversed. Okay, so now let's try number 4. Number 4 is a typical question. Okay, and of course, in your calculus class, you're going to see many layers of such composition. Okay, because you would imagine, well, right now we're just doing 2 layers. In your calculus class, you're gonna have 3 layers, 4 layers, 5 layers, 10 layers. I don't think they're gonna go to 10 layers, but at least sometimes you get 5, 6 layers. And you handle them the same way. Okay, you handle them the same way. Okay, so in the exercise I give you, it's just 2 layers. Okay, and later after we're done with these, and I'm going to give you I'm going to show you a question from a calculus textbook, which I have it right next to me, and I will just show you for real. Okay, so these would directly benefit you in next semester. Some of you might be taking summer class, right? So now I want you guys to try this. Can you try this? I think if you get it, you get it. If you don't get it, we keep trying, right? I'll show you some more. So how would you decompose this guy?
I made a cotangent x g of x, and then I made f of x sine x.
Can you say it louder?
For g of x, I got cotangent x, and then for f of x, I got sine x.
That's perfect. That's perfect. Okay, you can see, you just peel it from outside layer by layer, right? Does that make sense? If you get that, you're good. You're good. So that's what I want to show you. Decomposition is just like that. So when you peel it, what you said, who said that? I couldn't tell the voice.
That was Bailey.
Bailey. Thank you, Bailey. Because what you see, okay, when you make this, right? This is one of the basic functions, isn't it? Remember the basic function, basic one? Okay, now I want you to understand why I call it basic one. Because I have these questions in my head, in my mind, when I'm designing the whole thing. Okay, so now, and then you see, okay, and now your U is cotangent x. Then you say, oh, is a cotangent x is simple function as it showed up in table 1, basic 1, and the answer is yes. So you just go from outside inside. Every function you see is going to be a simple function. Does that make sense? That's what you do. That's what you do. Okay. I'm so pleased to hear that you guys really got the hang of it. So then you're going to do f of x equals to sine x. These are just placeholders. You can call them u and you can call them g. And do you know how to verify that? Do you know how to verify that? You do want to verify that at the beginning because we just learned this, right? So you do want to verify that. So when you verify that, you just follow the definition. You just follow the definition. Make sure you verify. Make sure you verify. Okay? So for example, in this case, and g of x is cotangent x, right? And then you continue. So f of x is sine of cotangent x. Okay, I think you guys got it. Okay, cotangent. Oh, cotangent x. Okay, sorry about that. Okay, you got it. Great job. Okay, would you like to try some more? In particular, I want you to pay attention to number 8 and number 9. Okay, so keep trying from number 5 through number 10. Okay, through the last one. I want you, because I think you guys can make them all. Okay. And I would like to see some submissions from your work, if you may. I'm gonna grab a question from your calculus text right here. Okay. I'm gonna get to, as you're working on that, I'm getting to chain rule. Just do your number 5, number 10, okay? I'm gonna grab a couple questions from. I think that's enough. That's plenty. That's all. Okay, number 5 to number 10. Any submissions? Decompose. Good. Okay, let's see. All right, thank you, Bailey. Thank you, Andy. Okay, I will go over them by the order that I received. Okay, you can submit a multiple. That's not a problem. Okay. Bailey's submission first and Andy's submission next. So let's look at Bailey's. Okay. Cosine x squared. Okay. And we got cosine x, which is f, g is x squared. And he verified f of g is x squared. Very good job. Okay. Bailey did a perfect job for number 8. Do you guys get it? Perfect. Okay. If you have any doubt, just do decomposing, the check part. And this part is great. Okay, very good job. You got it, right? It's a reversal of order of operation. So if you know order of operation, just reverse it. Just reverse it. Very good job. And so let's see Bailey's work, Andy's work. Andy did number 6. So his f of x is the square root of x, is g is 2 minus e to the power x. That's perfect. Okay, very good work. Very good work. F is square root of x. G is 2 minus e to the power x. Very good. That's it. You got it. You got it. Okay. Excellent. Any other submissions? Anybody tried a sine cosine square x? Anybody tried, right? Number 8 and number 9, if you look at them, what's the difference? You have a lot of other similar questions. What's the difference, right? We did number 8, just how about number 9? Anybody tried a number 9? For number 9, we need to understand is a cosine x squared. Okay, so these two are the same. So the order is different. Okay, so number 8 and number 9. So let's put number 8 and number 9 in the order. So you always have to be clear about the basic things, right? So if the number 8 is about x squared. So if you look at the from the functions perspective, right? So x, you know, you're gonna do x squared first, right? And after x squared, we do cosine, you know, x squared. That's the order. And this other one is that you have x as the input, and we do cosine x first. And then the next one is cosine and the square, right? So that's simply, so that order determines that which one is f, which one is g. Okay, so with that understanding, can you tell me what is the f, what is the g? You will make this u, right? We'll make this u. So if for 8, right, and Bailey has an answer, Bailey's answer f is a cosine x, right? G is x squared, right? That's the f and g. But for number 9, what is f, what is g?
F would be x squared, and then g would be cosine x.
That's right. Okay, so f will be x squared, and g, and this change, this difference in order determines whether you're going to get it right or not. Okay, so always go back to the basics, okay, the order of operation, and you reverse it, right? So which one is done first and which one is done second? I think number 7, you should have no problem. Number 5, you shouldn't have any problem, right? How about number 10? Number 10 is a function you're going to see very often. Okay, you're gonna see it in Calc 1. You're going to use it in Calc 2 as well, a lot. Okay, and it's not difficult to make the decomposition, even though the differentiability has some problems here, right? But at least we know how to decompose it. And the g of x is the absolute value of x. Okay, so that's, I don't expect any other questions. If you need more practice, you can do the B, you can do the 43B. So let's look at some real questions you are going to encounter for your calculus class. Okay, these are the real questions I just copied from that text. You can see there are many more layers. There could be many more layers than just 2 layers, right? You can have 3, 4, 5 layers. You could have 3, 4, 5 layers, right? You see that? So for example, this one. Okay, so for this one, you need to understand it's a tangent n times theta. And then the square. Okay, so you're going to peel layer after layer. Even though this looks like it's 2 layer, it's actually 3 layer. It's actually 3 layer. Okay, so let's do layer after layer. The first layer would be that this guy is a u. Okay, so U is that. Okay. The next layer is this guy is going to be your V. You can feel free to introduce a variable implicitly or explicitly, and that's n theta. So this one you probably could call it whatever x, right? And your last layer. So this is going to be related to theta. Okay, so you not only is going to have, you're going to have f of x, you're going to have 3 layers. So f of x equals to x squared. And g of x, you're going to have g of x is going to be tangent x. And you're going to have h of x, which is, well, if you call it theta, that's fine too, right? You can call it theta or x, n times x. Okay, so you have we have 3 layers here, right? It's seemingly 2 layers, there's actually 3 layers. Okay, so let's look at the next one. Okay, I'm gonna give them a number here. Number 1, it's differently numbered from the text. Okay, it's from that textbook. Number 2, it seems to have 2 layers, but it's 3 layers. Okay, it's 3 layers. So the first layer will be what? E to the power x, right? And the next layer is sine x, and the last layer is 2x. Do you guys see that? And you can verify. Okay, for example, let's backtrack a little bit. Verify. Can we verify? Okay, so when we verify, it's going to be F composite G composite H. Theta. Okay, so what you get? You're going to have F. Can you guys do this? H of theta. Okay, so to be able to verify, so then you know you get it right or wrong. Okay, you don't need to look at the answer key, you know whether it's right or wrong. Okay, so F of G of H of theta is what? H of theta is n times theta. Right? And the next one is F of G of n theta. So that's going to be tangent of n theta. And last, F of x is being squared. So this whole thing is being squared. Being squared, which is exactly this guy. Okay. Got it? So now how about you guys work on 2, number 2, 2, 3, you know, if you, it's 4. Number 4 actually is super easy. Number 5, you see more and more layers, right? There's more and more layers. And this one, 6, 7, I think you guys get it. If you get the hang of it, you got the hang of it. You are already doing homework, partial homework for your Cal. You're already getting the credit for your. Well, I cannot give you credit for Cal. You will be getting those credits. Okay. Just layer after layer of peeling off. Reversal of order of operation. You got it? Anybody want to share? 1, 2, 3, 4, 5, 6, 7. How many do I have? 6. 7 questions. Feel free to try them. So many layers, right? Because we ran out of symbols. It's create your own symbol. As long as it's a well-defined function, you can use F, G, H. Good job, Bailey. Okay. Everybody is welcome. Your work is welcomed. Okay. Very good. Excellent. Perfect. You did a perfect job. That's all you need to know. Okay. You can see he's doing that. And he probably did a lot of those things in his mind, right? And he got them right. And eventually, when you are in calculus, you actually would not need it. You wouldn't need it to introduce these intermediate variables because that's going to be too much work. That's going to be, well, I wouldn't say too much work. It's at the beginning it's necessary, but in time you would not need it. Okay, so that's what I'm hoping for. You would not need it to do U, V, W, X. You know, you run out of symbols. You would not need that. You just peel it off. You use your. It's like peeling. What do we? What are you? Guacamole? No, guacamole is not peeling. The corn. So there's in my favorite Mexican food. That was a you peel off the layers of corn peel, right? And make that, what do you call that food?
Tamale.
Tamales. Yeah, it's like peeling off the tamales. Does that make sense? It's like peeling off the tamales. You from outside inside. That's what you do. Okay. All right. You make my mouth water, as I mentioned. Well, I made my mouth water. But anyway, so you got it. Great job. Anybody else who would like to submit? Come on, guys. Is that fun? Is that fun to do? I think you guys would enjoy it. Number 4 is very straightforward, right? Number 4 is very straightforward. And let's focus on number 5, 6, 7. How about that? 5, 6, 7. And we're going to pass this today in the next section.
We can't see the questions.
Sorry?
We can't see the questions.
Oh, sorry, I forgot to, I'm sorry, I forgot to share screen, my bad. 5, 6, 7. Well, whichever you take your fancy, okay? But you may like to write them all down if you don't have the textbook or calculus textbook yet. And you can practice, okay? Because we're gonna pass this, we're gonna get to some other stuff. I think you got the hang of it. Could I declare that? Okay. Decompose. Decomposition. All work of submission is welcome. Yes, wonderful. All right. This is great. Thank you, Mikhail. Oh. Download. It takes on a pretty challenging question. Let's see if we got it right. You mean number 5, right, Mikhail? So your f is sine square x. Your g is e to the power x. Your h is sine squared tx. And let me see the work you check. FGH, g of sine of t, sine square of t, and then e to the sine square. You are right, but not complete. Okay, because if you look at sine square x here, right, in terms of FGH, when you compare the FGH, you're right, but you will not be able to complete that question in your calculus class. Okay, because you will need to find the derivative. To find the derivative, you have to decompose even more. You follow me? We have to decompose even more in order to apply the rules of derivative. Okay, so what you have done here is correct, but incomplete. You get it? All right, so let me show you. Did you guys write it down? It's right, but incomplete. Okay, Bailey, let me look at Bailey's. Bailey's attempt. Okay, the same question. So let's share Bailey's. So then we'll compare these. Then we will, new share. Yeah. So in this question, you actually have so many layers. The first layer, you need to recognize is a sine squared, right? It's the whole thing squared. So your first layer is x squared, and your next layer is sine of this x. And your next layer is e to the power x. Very good. And then sine, and then x squared again, and then sine of t. This is the details we want, Mikhail. So you need to decompose them more. Okay, you need to decompose them more. Got it? You need to decompose them more. And until each one is a simple function. You see, this one is a simple function. And this one is a simple function in basic 1. This one is a simple function, and this is a simple function, and that's a simple function. I coin the word basic function. Right? The one that we saw earlier, right? Not this one. Okay. Try number 2. All right. You got it, Mikhail? Right? So you need to decompose them more. You decompose until, okay, every function you see is a basic function. Every function is a basic function. So in your mind's eyes, you see the basic functions, okay? So good job, Bailey. Good job, Mikhail. So let's do this together. Let's do this together. Okay, I would say this is probably one of those hardest ones of all, and let's re-enhance our skill over here. Okay, over right here, we need to recognize, okay, the sine square of something, it really means sine of this guy, the whole thing squared. So your first layer, okay, I'm going to show you how you get your layer, okay? The first layer, you're going to make this guy a simple function. Doesn't matter what you call it, okay? You can call it heart. Okay, you can call it, say, whatever. Call it, let me give a name, call it heart, right? And what is the heart? Right? I'm going to show you that process. The heart is this guy, right? On this guy, if you make this simple, I'm going to call it spade. And what is spade? This is a spade. Okay, on your scratch paper, well, this is the work I meant you like to do it on your scratch paper, or you have your mental process, right? So if you look at this guy, that's a simple function, isn't it? Right? So this should remind you of one of the basic functions, and this guy is x squared. It reminds you of x squared, or something squared. It's simple function. And this guy reminds you of what? Sine x, right? This guy reminds you of sine x. In basic one. Okay? Now, E. Over here, I'm going to call this guy, let's see what name we're going to call it, right? We're going to call it that one. How about that? Ooh, here. That equals to that. And sine square of t, we understand that's the same as sine of t squared. Right? So to make that happen, we're going to make this guy what? Let's call it something like that. Right? So now it's x squared again. You see that? Each one is a simple function. And of course, this guy is e to the power x. And they are from basic one table. Okay, they're from basic one table. Okay, and last but not least, that's a sine of t. Do you see that's like a chain? Does it look like a chain? A chain of basic functions. Do you follow me? It's a chain of basic function. When you take a derivative, when you learn chain rule, you take a derivative, and you're going to use this chain to get your answer, to get you to get to what you need. Okay, to get to what you need. Okay, does that make sense? So now if you look at what Bailey did you guys write this down? I want you guys to write this down. Okay, so this is sine of x. So each piece is a simple function, basic function. So how many layers we have? 1, 2, 3, 4, 5. 5 layers. 5 layers. Okay, it's a chain. It's a chain. From outside, inside, outside, inside. Okay. So you can call them whatever you want, really. You can call them whatever you want. Okay. F, G, H, W, U, whatever. Okay. Now, number 6. Can you do number 6? Can we do number 6? How do you do it? This is one layer, right? I'm going to copy the whole thing. Okay. And this is going to be 2 raised to the power of bologna. Okay, omega. And what is omega? Omega is that guy. Oh, sorry. This guy. Right? And for this guy, right, you see that chain, right? You see that chain, and this omega is specified. And this guy is going to be triangle, right? And triangle, make it a heart. Oh, sorry, this is triangle. Okay, each one is a basic function. You can see that each one is a basic function. Okay, so last one. Let's do this last one. Okay, so how do we peel this off? Let's peel this tamales. Okay, so again, you can eat the yummy inside, right? So this first piece is going to be what? Whatever, any symbol you want. Okay, any symbol you want. Okay, cosine. And then our heart, the heart is that guy, right? And this guy, if I can keep it simple, right? It should equals to that. You guys get it? It's a chain, it's a chain. Okay, and over here, spade. All these symbols, they're just a placeholder. So that spade is equals to that guy. Okay, and tangent, well, this is something we did before, right? This is we did something before. This is what we did before. So that would be replaced by whatever, right? And yeah, that equals to pi x. Each one is a simple function. We have a root, we have a basic function, cosine, cosine, square root of x, sine x, tangent x, pi x. See that? How many layers we have? You can just count, right? Do you think you got the hang of it? And of course, I'm not going to be assessing you on these things. Okay, your professor in calculus class will be assessing you these things, and it will be on a different setting. If I give you a quiz, but that will be just 2 layers. Okay, I'm only quizzing you on 2 layers. Okay. So these are the fun exercises that I wish to do with you guys. Okay, and the next topics we're going to go over to. Okay, it's 9 o'clock. We will come back to 44A, but I wish to take you guys to, there's a big section of trigonometry. There's a big section of trigonometry after this. Okay, 44A, we're gonna come back. We're gonna come back to it, okay? And that's about mathematical induction. And the next section, trig 12, this is big sections of the trig. We have covered trig, so I don't think I want to spend more time here. Okay, but these are the exercises you can do. We covered the formula, didn't we? We covered these formula, right? We covered these formula. So these are just additional exercise for you guys to do and see and practice. Okay, those derivings from your trigonometry experience. Of course, this is a lot more exercise. Say, for example, let me show you some of these tables. Do you see that? Do you see these? Do you see your notes on your screen? Do you guys see this?
No, it's still on the other. Oh, now we do. Yeah.
Okay, hold on. Let me move to this side. Stop share. Let me show you. Yeah. Do you see these? Do you see that the table formula?
Yeah.
Okay, so we have covered these, right? And this is the formula that I think you might need. Okay, but if you can derive them yourself, right? Did we talk about the deriving? I think we did. If you go back to watch those sections, what I encourage you guys to do is you derive your own. And that's how you become the master of it. And you don't have to memorize, okay? All of these exercises are just to practice these formula. We won't have time to do it in this class, but if you when you practice them, you have questions, you feel free to ask me, okay? And I'll be happy to answer your question. And these are deriving identities. Trig 19 is an interesting session because you will be using these techniques or these algebraic basic skills to convert the product to sums. We had a similar exercise before, which how we use a half angle a lot, right? But these may also show up in your Calc 2, okay? When you do the integration and you have product, like in order to integrate, you have to convert the product to sums or differences, okay? And we have these, and sometimes you have sum to product to sum, double angle, and all of these things you guys can practice. And on these, issues, we've done similar problems before, and so we're not gonna. So these are just a review of trig again. And solving trig equations, we have a more more complicated equations to solve, but they're essentially similar in ideas, and it requires more algebraic skills, okay? Require more algebraic skills. The next section I want to get you guys to is to simplify. Okay, so let's look at trig 24A. Okay, let's look at trig 24A. Okay, so could you guys look at trig 24A? Do you guys have that page in front of? Because I'm gonna move to the next section. Yeah. You guys have that? Do you guys have the notes in front of you? Okay. So I'm gonna have a change of screen. Okay. I'm gonna tell you where those where are you gonna need, when you're gonna need to do that. Okay, there's a chat message here. Thank you, Mikhail, for the prompt. Page 121, page 121. Thank you, Mikhail. Okay, so I'm going to share with this screen to say, first of all, 24A is the kind of questions you are going to encounter in Cal. The setting will be like, okay, trig 24a. Okay, so the situation will be like you already took your derivative. Okay, so pretend you already took your derivative, but you need to simplify. Okay, you need to simplify. So the question is, can you simplify? And the typical technique of simplifying these is factoring. It's factoring. For example, right? Take the first one, for example. Okay, we start with a simple one, and then we get to some other stuff. Okay, cosine x minus 3 times sine square x and cosine x. Okay. Simplify. Then I also mentioned that is final answers in product or quotient form. Why final answer in product or quotient form? We have addressed that issue. Why we prefer product form or quotient form? Because then we can apply principle number 5 and number 6 when we need it, right? So in this case, for example, you use this factor, right? 3 times cosine x, and then you have a 1 minus sine square x, right? And then what? One minus sine square x is a cosine square x, right? So in the end, you get 3 times cosine to the power 3x, right? Then you're done. Okay, so let's look at another scenario. Let's look at another scenario. Okay, this one I'm looking at is number 7. Simplify. What you have this pretending you are in calculus class. Okay, and you have learned how to find derivative, and you found derivative, and this is applying quotient rule, chain rule, whatever, right? And you encounter this expression. Can you simplify that? Can you simplify it properly? So let me tell you how these exercises are created. Okay, I created most of these exercises here. Okay, so what I did is that I, reflecting on my teaching calculus classes experience, right? So I took some of those exercises from your calculus textbook. So I took the derivative, because I'm not going to teach you to taking derivative. So I took the derivative, and then we end up with something like that. Okay, our students, the student I had taught before, they can do this up to this step, but the next step, some of them might make a mess out of simplification. But that simplification step is important. Why is it important? Because you have a next step follows, right? You have following steps after the simplification. And then what you do? Then you mess up everything if you don't simplify this properly. You follow me? And that's a basic algebra skill. That's an algebraic skill that we need to, we need to review. So can you guys do this for me? Right? You will multiply this guy with 2 with sine square, right? So you're gonna have 2 times okay, and minus sine squared x and minus the cosine squared x. Oops. And sine squared x minus cosine squared x, that's together, that makes what? Makes 1. So these are not very complicated situation, and you need to be able to do it correctly. Okay, after you have done this step correctly, you go to the next step. Okay, there are other steps, to find critical points and to find whatever. Okay, some basic operations such as number 6, number 10, number 9, right? So these are the exercises I encourage you guys to practice, okay? And you're working towards your credits for your calculus classes. Okay, so then move forward. I move forward where I have 24B, and some of those exercises are a little bit more complicated, and many of them are taken from calculus classes textbook. Okay, more algebraic based practice. I want to take you guys to page number, this is page number 159. Okay, the parametric, we're going to do it later. So right now, today, we kind of focus on the basic algebraic skills, right? So look at basic 45A. The one we just talked about was trig 27, right? Trig 27A, something like that. Yeah, trig 27A. Wait, is that 27? 24A, I'm sorry, 24A, my bad, 24A. Never mind. Basic 45A. Okay, let's look at basic 45A. So you can see some of these topics we repeat. We've done something, we come back, we do it again. Like basic 45A. That should be on your notes on page 123. Okay, there's A, there's a B, if you like to practice some more. And there's a B there. Okay, you should be able to operate these expressions in 45A fluently. You follow me? And express your work nicely. Express your work nicely. Okay, and take an example. Take an example here, right? Take number 4, for example. This is typical taken derivative question. Okay, basic operations. Minus the square root of x h. It's a complex fraction. It's a complex fraction. And how do we operate it? Well, you will have to simplify this, right? So this piece of algebraic work is is necessarily done well. It has to be done well within the setting of your, finding derivative or whatever. Okay, so what you do, the first thing you do, what you do? Anybody has any idea? What would you do? How would you simplify it? Remember we did earlier on, we did 35A, right? Remember 35A? Those, you're being quizzed on, right? How about this guy? This is involved reducing fractions, complex fractions. So one of the things you can do is multiply by 1. Principle number 1. Anything times 1 stay the same. Okay, of course, the one we chose is going to be the common denominator. Okay, and then what? You take this guy to multiply each. Okay, and you take this guy to multiply that. I make the font a little bit smaller, okay? And then the next step, you reduce it, right? So eventually you have a root x left, right? And this piece, you're gonna have a root of x minus h. Does this look familiar? It's similar to one of the questions in basic 35, right? Basic 35. And then what you do? Rationalize the numerator. Rationalize the numerator. Do you follow me? You're gonna rationalize the numerator. How do you rationalize the numerator? The conjugate of this guy. Turn positive. Conjugates. Okay. Equals to the denominator. What is the denominator? The denominator has this guy. And then it has this guy. And over here, you're gonna have a squared minus b squared. So this guy squared. And this guy squared. Right? And then what? You know the rest, right? You know the rest. This is familiar. So this is just x minus x plus h. You should know the rest, right? We did something similar. You guys see how much it takes? It takes some basic algebraic skills. And this is a realistic calculus class question. Okay, of course, I'm taking it out of the context of taking derivatives and all of that stuff. But it requires, at the core, it requires our algebraic skill, okay? So let me quickly finish this one. And you're gonna see a lot of similar situations. For example, number 8, number 7, number 8, which one you wanna get to? 7, 8, 9, 10, 7, 8, 9, 10. Just pick one, okay? We're running out of time. I'm not gonna get to another new topics. But I wanted to show you the importance that you have planned for continued practice throughout the summer. I would say throughout the summer. If you take summer school, well, you need to practice nonstop. If you take calculus 1 in the fall, and you should not stop practicing throughout the summer. But the other thing I want to tell you, I do not teach in the summer, but if you guys have any questions, don't hesitate to reach out to me. Okay, I'll be happy to help. I'll make time for you. Okay, but you must take that initiative to practice these exercises, some of these things. Don't just every page you flip the pages, right? Yes, the notes come to you for free, but I have an agenda in these notes to prepare you, to better prepare you, I hope, for your success in the future classes. Okay, so don't just flip the pages not doing anything. Flip the pages and do something and do the practice. Okay. Okay, so try some of these. Okay, so I'm gonna use the rest of the time to show you some examples of how to do these things. Okay, and then you do the practice. All right. Take number 7, for example. Right? This thing looks a bit messy. Okay, it looks messy, but this is really something you're going to see and in calculus class. Some of the student tells me, okay, some of the student who took calculus class, they come back and they will say, you know, the algebra in calculus class looks weird. Okay, that's what they say. That's their comment. And I'm going to tell you why they look weird. I'm going to tell you why they look weird. Okay, so I'm going to make the fonts larger on this one. They do look weird. I agree. Oh, no, sorry, 250%, 250%. They do look weird. But what is the algebraic counterpart you might have seen before? Right? They have this guy, they have that guy. Gee, it does look weird. But in your basic algebra, guess what you have seen? You definitely have seen something like this. A minus x squared times a to the power of -1. How does that look? Or maybe even this is y. Or you might have seen something like this. Y over a. Does that still look weird to you? Does that still look weird to us? Maybe a little more familiar, right? Yep. So all the symbols we learned in elementary algebra, intermediate algebra, those x, y, z's, they turn into baloney. They turn into baloney. For example, okay, to illustrate this, okay, to illustrate this, number 4 we did, right? So number 4 we did. So number 4 we did. We just did this, right? We just did number 4. Right? Number 4, in your calculus class, in your algebra class, it might be something like this. Maybe like something like, it might be something like this. H. So in our elementary algebra class, intermediate algebra class, we saw something like this. This is what we saw. And in calculus class, it turned into something like this. You guys see that? This is what I meant. The symbol you learn, A, B, X, Y, Z, they turn into baloney. They blossomed. They blossomed. Okay. So now, how are we going to simplify number 7? Right? Pretend you are in calculus class. How are you going to simplify this? This looks weird and messy, right? It looks very weird and messy. But if you know how to do that, and you also have to think about the roots, right? You have to think about the roots. So one way to do this, I'm going to show you 2 ways if we have time. Okay. One way to do this is you put it in the form that you're familiar with. This is a power half, right? Power half will turn into root. Turn into something like that. Okay. Power negative half. Power negative half, what would that be? That's going to turn into that. That's what it is. Into a familiar form. Into a familiar form. And you have to simplify this. You have no choice. If you don't simplify this, and there are 3, 4, 5, 6 steps after this, then you won't be able to get them. Okay, and not only you have to be able to simplify, you have to simplify this correctly. Okay, because otherwise everything else will be ruined. Right? So what you do, you can view this as, over 1 if you wish, right? Divided by 1, or it's just keep it the way it is. I just want to show you that they're the same, similar situation. And you can just put this x on the x squared here. Okay, so in our familiar form, and next, what do we do? What do we do next? We multiply by 1. Okay, the choice of 1 is going to be the common denominator. Does that sound familiar? Okay, equals to, and you take this guy, multiply that. Okay, so this guy times that is going to be that squared minus root 1 plus x squared multiply root 1 plus x squared. So this guy multiply that, this guy, that's going to make it just x squared, right? Denominator, you're going to have this one. You need to put it in parentheses, and then you have this guy. Patience, lots of patience. And these 2, of course, reduced, right? So let me show you the next step. Does everybody follow me? Okay, so this piece is just have x squared left, right? This is just x squared left. And over here, what do we get? It's just 1 plus x squared. What do you do with the denominator? Nothing, absolutely nothing. You actually will get to this form, and you're done. You're done. And from this form, you can proceed with whatever you have to do. whether it's a solving for, or whether you set it equal to 0 to do something, or you do something else, whatever you do, right? And you need to be able to carry out these steps. You can skip some of the steps as you're getting better properly, correctly, okay, correctly. Another, I promise you, I'm going to show you another method to do this, right? The other method to do this. The other way. The other way. Okay. The common strategy of doing this, simplify these kind of expressions, is that when you have a negative exponent, when you have something like that, you factor it out. You factor it out. Okay. So what you can do is that you're going to factor this out, but we don't have that in here. So what you do is that you're going to make it. Okay, so you're going to put it one here, and you're going to multiply another one, which is a positive. You basically have created this piece, you created, right, is a 1. You multiply by 1 here. Okay, this 1 is replaced by what? By this guy. This guy, these two, they have the same base and opposite exponents. Same base, opposite exponents. You guys see that? Same base, 1 plus x squared, opposite exponent, negative half plus half, that's a 0. So that's essentially what it is. 1 plus x squared to the power of 0. That's what I was doing there. You follow me? So this guy is turned into that. You see it? And then you can factor this piece out. You can factor out these pieces. Okay, if you want your work to look nicer. Okay, because the previous way it can look messy. That's why you need to do it well. Okay, so now on the top, you can factor out this guy. Oops, sorry. Okay, you can factor out that guy. And inside, this guy is factored out, right? And you have these two, sorry, you have these two, right? Same base, same exponents. So that's going to be 1 plus x squared. Minus, because this piece is factored out, so you just have x squared. You guys follow me? And the denominator is that guy. And this negative exponent will be flipping down. You can have it flip down to the numerator. So here, this is just 1, right? This is just 1. Right? And you have this piece flipped over to the positive exponents. Okay, so these two combined is really the third. You can see in the whole process, I didn't use any special skills, right? Just a basic skills such as b to the power 0 equals to 1. But b turning into what? B turning into what? 1 plus x squared. Right? And b is not 0 because x squared is always greater than or equal to 0. So this is always not equal to 0. So to the power 0 equals 1. Right? And power, right? B raised to the power m multiply b raised to the power of n equals to b raised to the power of m plus n. You know, we're really just using these very basic skills. Do you follow me? So in the whole process, that's what we used. Okay, so I think that's all for today. Keep on practicing. Keep on practicing. You have lots of work to do. If you really want to prepare yourself well for your success, I mean success, okay, success. You do all the practice you can. These questions on the notes, I have every semester I update it, okay? So it has become a bit more in volume, but I really hope that these material will really, really help you. It can only help you if you practice them. Okay, so I'll see you guys tomorrow. We will continue. And of course, we still have lots of material to cover. We cannot possibly finish. Okay, but even for those exercises we did not cover in class, don't ignore them. Okay, don't ignore them. Okay, practice on them. If you have any question as always, okay, even after the semester is over, feel free to reach out to me. Okay, I'll see you guys tomorrow. Have a great day. I'm sorry, did I leave any mess? Okay. Thank you, Andy. Appreciate it. Thank you, Mikhail. Thank you for all the responses, all the participation, and keep on practicing. Keep on deriving. Okay. See you tomorrow.
Thank you.